Hello friends, I welcome you all to our channel Board and Beyond. Okay, so friends, today we have started mathematics for standard 9th CBSE. Okay, so those of my friends who want to actually watch this video or who wants to actually first take the preliminary session of 9th and then graduate to 10th can do that now. Okay. So the topic which we have chosen or the chapter which we have chosen to start with is the probably most difficult chapter that you all people think of. Okay, this is surface areas and volumes. Okay, actually to tell you frankly, friends, there is no difficulty here, right? Only thing is that while doing the calculation, you have to be mentally and physically present in the examination. You will be able to solve it, right? Okay. So let's try to understand what do we mean by surface area. So when we say these two words, actually it is surface and area, right? So first let us quickly understand what is surface. So surface is any flat structure is called a surface, right friends? Just for an example, just to illustrate, if you are able to see this, then this what you see the white is the surface, right? This has got a length and a breadth, okay, right? So this is a two-dimensional figure and it has got a surface, right? And then what is the area? Area is nothing but the spread of that surface. How far it is spread is called the area, okay? And then let us understand volume as well. What is a volume? The material content of an object is called the volume, or the material which the object can hold inside is called the volume, right? So if it is an open container, it will hold something, and if it is a closed solid figure, then the material content of the object is called volume. So there are different types of solids around us. So we will stick our discussions to the solids of regular shape, right? That is, it has got a flat surfaces. It can have a curve, but it should be a regular shape, right? So friends, with this understanding, let us take the first regular shape of solid, right? That is, we call it as a cuboid, right? So cuboid is basically a solid, okay, which has got rectangular surfaces, right? So just to imagine that you can look around the four walls of your room, okay? So that are basically the different surfaces, right? The four surfaces, and the roof and the floor. Those are the two surfaces. So totally a cuboid has got 6 surfaces: 4 walls, roof and floor, right? Now the area, sum total of areas of all these surfaces is called the total surface area of the cuboid, right? But we should also understand what is lateral surface area, right? So lateral surface area is nothing but the area of the 4 walls which is around you, friends. I hope you are getting it. So why do we understand lateral surface area and why do we understand total surface area? Let us say if you want to paint or if you want to distemper your house or your room, okay, so you will be majorly doing it on your 4 walls and maximum at the roof, but you are not going to paint the floor, right? You are not going to distemper the floor. That is why we should have a concept of lateral surface area and the total surface area. And the total surface area is that if you are going to paint everything, right? If you are going to distemper everything, or if you are putting some design on the entire surface area of the room, that is including your roof and the floor, then it becomes total surface area, right? So let us first try to understand what is the lateral surface area of a cuboid. So I have drawn a small figure here. Let me just explain it to you. This is a cuboid, my friend, okay, which has got length L, breadth B and height H, okay. So this is a solid figure, right? So let us understand lateral surface area. I denote it by LSA. Lateral surface area of that cuboid. So lateral surface area, as I said you, is the area of the 4 walls, right? So the first wall is A, B, C, D, okay. So area of A, ABCD. Okay, plus this is one figure, then this is DCFG, right? DCFG plus the back side HEFG, right? Plus ABEH. You are getting it? So these are the four walls. The sum total of all these area will give me the lateral surface area of a cuboid, right? So all these, as I said you earlier, it is a rectangular faces. Okay, so area will be length into breadth, correct? Right. So ABCD is nothing but L into B. Sorry, L into H. You are getting it? LH plus DCFE. DCFG will be B into H. Back side again it will be LH plus this side again it will be BH. Right, friends? So what is happening here is that it is giving me 2LH plus 2BH, which can also be written as 2 taking common outside, and I can take H even. So L plus B. So friends, this is the lateral surface area of a cuboid, right? You got it? Now coming on to the total surface area, right? So total surface area of a cuboid is nothing but this plus roof and the floor. Okay, so I will write this expanded form. So 2LH plus 2BH plus L into B and L into B. So L into B plus L into B. I just simplify and write 2LB. Right, friends? Now this gives me as 2 into LB plus BH plus HL. Right? So this is the total surface area of a cuboid. Okay? We will try to jot it down here so that I can use it in the this thing. 2 into H into L plus B, right? Total surface area will be equal to 2 into L B plus B H plus H L, right? Now we have understood lateral surface area, we have understood total surface area. Now let us understand volume as well. Okay, so volume of a cuboid. So volume of a cuboid is basically L into B into H. So what happens is volume of any solid figure, right? If it is an open container or if it is a solid figure, so in majority volume of a solid figure is nothing but area of the base, right? Area of the base into height, that is the volume. Okay, provided that is a regular shape, right, friends? Cylinder, cuboid, cube, all these are regular shape. That means your height is standard, it is vertical, but the same cannot be applied for cone, right? You are getting my point? Because the area is the height is slant, it's a triangular shape, right? It cannot be applied for a cone, right? So this becomes L into B into H. This is very simple. So volume is equal to L into B into H, right? So we have understood about lateral surface area, total surface area and volume of a cuboid, right, friends? Now let us try to understand cube. Okay, so before we go to cube, let us first understand what do we mean by a cube, right, friends? So a cube is a solid, okay, and it is a special type of cuboid in which length is equal to breadth is equal to height, right? So that is a cube. Now coming on to finding out the lateral surface area of a cube. So lateral surface area of cuboid is how much, my friends? 2 into h into L plus B, correct? Now, when I am talking about cube, what happens? All these dimensions become L, okay? Or it is all same. You can consider it as L or A or whatever you feel like, right? So this becomes 2 into L plus L, right? So this becomes 2L into 2L, which is equal to 4L square. You are getting my point? So this is lateral surface area of a cube. LSA of cube is nothing but 4L square. You are getting my point? Now coming on to the total surface area of the cube. Okay, so total surface area of cube. So let me write. Cube is this. So cuboid, how much did we get? 2 into LB plus BH plus LH. Right? Here. Now, what we are going to do is that we are going to replace everything with L here. Okay? That will give me the total surface area of a cube. So this becomes L square. This also L square plus this also L square. So this becomes 2 into 3L square, which is equal to 6L square. Right, friends? So this is total surface area. Total surface area is equal to 6 into L square. You are getting it? Now we will find out the volume as well. Right? So volume is equal to how much, my friends? For a cuboid, it is length into breadth into height. Now, when we talk about cube, what happens? This becomes L into L into L, okay, which is nothing but L cube, right? So volume. Right? We'll keep it here. Just for your understanding, let me tell you, when we are talking about the lateral surface area of a cuboid, we understand that a cuboid is a solid figure, okay, which has got different surfaces, okay, and those are rectangular in shape. Okay. Now, when we are talking about a cube, we also know that cube also has got different surfaces, and all those surfaces are actually square in shape, right? So this will basically give you an idea why these things are coming here, right? So with this, let us move on to problems. Let me just take down the first problem. Okay, friends, so I have taken down the problem here. The problem says that the pent of a certain container is sufficient to pent an area equal to 9.375 meters square, right? So how many bricks of this dimension can be painted out of this container, right? So our approach will be, first find out the total surface area of the brick, okay, and then divide this area by the total surface area of the brick will give me the number of bricks which can be painted, because paint remains same, right? So let's do that. So let's try to solve it. So TSA, total surface area, okay, of brick will be how much? 2 into LB plus BH plus LH, right? Because brick is a cuboid, right? So this is nothing but 2 into L into B. This into this is nothing but 225. Do we all agree to it? Then BH, this into this, that is equal to 75. Plus this into this, we'll do it here, 22.5 into 7.5. That is 168.75. Right? Okay. So let it be there. So the total is how much? 168.75 plus this 225 plus 75 is nothing but 300. So 300 plus 168 nothing but 468.75, right? Right? You're getting my point? Now when we multiply this, okay, so this becomes 0. So it becomes after 2 decimal, that is equal to 973.50. Okay, let me write it slightly bigger. 973. 973 point, sorry, I think 9 0 937.50, my friends. Okay, so this is area, so this is centimeter square. Now the catch here is that the dimensions given here, friends, okay, are different. Okay, that is, this is 9.37 meter square, right? So rest of the sum I am doing it here. So 9.375 meter square into 100 divided by 937.5. You getting my point? Okay. Now friend, is this all correct? What I have done is right? No, it's not right. Why it is not right? Because this is into meter square. So whenever there is a square and you are converting meter to centimeter or any unit to any unit, then the multiplication will be 2 times, not 1 time. Right? So into 100 again. You got it? Had this been centimeter, I would have multiplied with 100 and it would, sorry, had it been in meters, I would have converted it into centimeters by multiplying 100. But since it is a meter square, I will multiply 100 2 times. If it is a meter cube, I will multiply it 3 times. Okay? And vice versa is also true. Right? If you are converting centimeter to meter, you will divide it by 100. But if you are converting centimeter square to meter square, you will divide it by 100 into 100. You getting it? Okay. Be careful. Right? So this becomes how much, my friends? 4 zeros, right? So 937, 1, 2, 3, 4, decimal after 3 digits. So this is gone. Sorry. 937 9375000 after 3 digits. So this is gone. I'll just, and this is 937.5. So again I will put 1 0, cancel it out. So this gives me how much? 100 bricks. Right, friends? So with the paint what is available to us, I will be able to paint 100 bricks. Right? So let's take down the next problem. Right, friends? So I have taken down the problem here. Okay, and this is not from your NCERT textbook. Okay, because I understand the questions are basically taken care of NCERT textbooks. So just to make your understanding or just to make your knowledge more strengthened, I have taken a different kind of question here, which is not from your NCERT textbook. Okay, so let's first go through the question. A field is 70 meter long, 40 meter broad. Okay, the length and breadth has been given. In one corner of the field, a pit is dug out. Okay, so let me try to make you a small figure, which I will have to rub it after this. So let's say this is the field, friends. Right? So this is 70 and this is 40, right? 70, 40, and a small pit is dug here, that is 10 into 8 meter broad, and depth is 5 meters here. So a pit is dug out here, okay, and the earth which is taken out, or the mud or the sand, whatever you want to consider it as, which has been taken out from here, from the pit, is evenly spread on the rest part of the field, okay. And we are expected to tell them, or we are expected to find out how much will be the rise in the level of the field, right? So there are two things here, friend. One is that I am taking out some volume from the pit, right? Some earth I have taken out from the field, and I have spread that to the remaining part, because I will not be spreading it over the pit also, right? So these are the two things that we should consider it here. The rest of the thing is actually fairly okay, right? So I'm moving this out from here. Now let's try to solve it, friends. So area of the field now, how much? Area of the field is equal to 70 into 40 is equal to 2800 meter square. Is everybody okay? Fairly simple. Now area, how much area is actually getting deducted from this? The area of this pit, right, that is 10 meter long and 8 meter broad, right? So area of pit, I am just talking about area of pit now, is equal to 10 into 8, that is equal to 80 meters square, right? So now remaining part of the field is how much? Remaining part of the field is nothing but 2800 minus 80, that is equal to 2720 meter square. You are getting my point? How did this come? This has come from 2800 minus 80, right? So this is the remaining part of the field on which I will be spreading the earth which I have taken out from this pit, which I drawn just now, okay? Right. Now the volume of the pit, how much material are we getting out of the pit? Okay, so volume of pit is equal to how much? 10 into 8 into 5, right friends? So 10 into 8 into 5, right? So this is equal to 400 meters, right? Meter cube. So this is the volume of the pit. Now what is happening is this volume of the pit, okay, every dimensions are same in meters, okay. I am spreading it across this, right? So what will be the rise in the level of the field? Rise in the level will be equal to 400 divided by 2720, right? So how much it will be? This is a meter, 400 meter cube, right? So I think we should convert it to centimeters, right friend? Or we leave it to meters also, it's your choice, so no problem. That is 40 by 272, which is 20 by, I am trying to divide and write it here, 136, which is equal to 10 by 68, which is equal to 5 by 34. I think we have to stop it here. So we can say area, the rise in the level of the field will be 5 by 34 meters, right friend? We can leave it in meter as well, no problem. Oh, I think it has not got covered, okay, no issues. So I'll just write it here, 5 by 34 meters. Right? Okay. So we can actually leave it like this also, friends, or we can actually convert it into centimeters also. It is absolutely your choice. Okay, but this is the this thing. So let me just take up the quickly next problem, and then we actually after this we wind up. Okay, right. So I have taken down the question, friend, here. The volume of a cuboid is said to be 1536 meter cube, right? And the length is 16 meters, given to be 16 meters, right? And breadth and height are in the ratio of 3:2, right? And we are expected to find the breadth and the height of this cuboid, right? So what is the volume of a cuboid, my friend? You can just refer it there, or it is length into breadth into height, basically. So volume of cuboid is equal to length into breadth into height, right? So that is equal to 16. Let us say this is ratio 3:2, right? So let us assume 3x and 2x. Okay, x is a constant there, 3x into 2x, and this would be equal to how much? 1536 as per the question, right? So this is volume is 1536, right? So this becomes 3 into 2, that is 6x square, is equal to 1536 divided by 16, sorry, you are getting my point? Okay, so x square, so this gives me that x square is equal to 1536 divided by 6 into 16, right, friends? Let us first try to divide this by 6. So 6 2s are 12, remaining is 3, 33, 6 5s are 30, remaining is 3, 36. So 6 6 are 36 by 16, okay, which is also equal to 16. Okay, so 16 into 16 is 256, right? So x is equal to how much, my friends? In this case, it is plus or minus root 16, right? Okay, so I'll further continue it here. Is it available? Okay, so I'll further continue it here. Okay, let's continue here. So x is equal to plus or minus 16. So x is equal to root 16. So x is equal to either 4 or minus 4, right? But since this is a side of a cuboid side cannot be negative, so we will omit this. So x is equal to 4. Now you have got the common factor, okay? Now x is equal to 4. So what will be the breadth? Breadth will be 3x, that is equal to 3 into 4, right? So 3x, which is equal to 12, considering x is equal to 4, right? Then height 2x, that is equal to 8. These are in meters, all dimensions in meters, right? So your answer is breadth is equal to 12 meter and height is equal to 8 meters, right, friends? So with this we will stop this session here. Just wanted to tell you, my friends, that a few of you may be aspiring to become engineer or a doctor, or for that matter become a scientist or something, okay? So the right time is actually now, okay? Because what happens is next year, that is from almost September 2021 or July 2021, you will be under pressure of scoring in board exam. You will not have any leisure time to study something extra, okay? And in that case, what happens is that if you want to prepare, you will have to basically spoil your year and then prepare for some competitive exams. So my effort here is that not just solve the questions which are available in the textbook, but I am trying to give I am trying to take out certain questions which are which are from different sources, so that your level of thinking increase, right? You start thinking in a different level, because this type of questions will actually make you think in a different level. For example, let's say the side of a cube is increased by let us say or doubled. The side of a cube is doubled. Okay, what will be the effect on the area? Area will be increased to how many times? For example, total surface area, or the volume will be increased how many times? One more important concept, my friend, let me tell you, not that is not very important as per your examination point of view, but yes, definitely you will take up some competitive exams, and there it will be really handful. Okay, so the question is, a cuboid room is there. Okay, cuboid room, basically length is different, breadth is different, height is different, right friends? And we are expected to find out what will be the maximum length of a rod that can actually fit in that cuboid room, right? So we can place it like in any position, but I want to know the maximum length of the rod, right friends? So the maximum length of the rod for a cuboid is basically, where shall I write? I'll write it here. That is, length is equal to maximum length I am talking about, L plus B plus H. Right? Maximum length. Yeah. Maximum length. L square, B square, H square. Right? I'll just confirm you over this in the next class, but we can actually derive it also very quickly. So this is length, this is breadth. So this is square root of L square plus B square, and I am talking about this, right? And this is H square. Yes, friend. So L is equal to, no problem, L square plus B square plus H square. So friends, this is what happens when you are actually knowing the underlying concept. You can basically come back, but if you have just simply remembered it or by hearted it, you will not be able to come back. Okay, so this is the maximum length of the rod which can be fit in that room, right friends? So with this, I'll close the session here. Let's meet up in the next session. Till the time, if you find that you have gained some good knowledge from here, share it with your friends. Okay, thank you so much. God bless you. Bye.